This is a review over the transformations unit. Transformations include translations, reflections, stretches, and compressions. The test on transformations will cover textbook sections 1-8, Exploring Transformations, 1-9, Introduction to Parent Functions, 2-6, Transforming Linear Functions, 2-9, Absolute Value Functions, and 5-1, Using Transformations to Graph Quadratic Functions in vertex form. A transformation is a change in the position, size, or shape of a figure. A translation is a type of transformation. A translation or slide is a transformation that moves each point in a figure in the same distance in the same direction. A reflection is another type of transformation that flips a figure across a line called the line of reflection. Each reflected point is the same distance from the line of reflection, but on the opposite side of the line. A reflection can take place over the x-axis or the y-axis or any other line that's given. Notice that when you translate left or right, the x-coordinate changes because the x-axis goes from left to right. It's a horizontal line. When you translate up or down, the y-coordinate changes because the y-axis is a vertical line. As you'll notice in the box, a horizontal translation shifts left or right. The x-coordinate changes. We use h for the value, left or right, that the coordinate changes. If it's moving to the left, the h value is less than 0 or is a negative number. If your movement is to the right, the h value will be greater than 0 or a positive number. For a vertical translation, each point shifts up or down by a number of units. We use k for the value that the point moves up or down. So if the movement is down, the k value will be less than 0, or k will be a negative number. If it goes up, the k value will be greater than 0, or k will be a positive number. For reflections across the y-axis, each point flips across the y-axis, causing the x-coordinate to change. So if x is positive, it becomes negative. If x is negative, it becomes positive. For a reflection across the x-axis, the point flips across the x-axis, changing the y-coordinate. So if y is a positive value, it becomes negative. If y is a negative value, it becomes positive. You can transform a function by transforming its ordered pairs. When a function is translated or reflected, the original graph and the graph of the transformation are congruent because the size and shape of the graphs are the same. Imagine grasping 2 points on the graph of a function that lie on opposite sides of the y-axis. If you pull the points away from the y-axis, you would create a horizontal stretch of the graph. If you push the points towards the y-axis, you would create a horizontal compression. Stretches and compressions are not congruent to the original graph. As you'll notice, with a horizontal stretch, each point is pulled away from the y-axis, so the x-coordinate changes. With a horizontal compression, each point is pushed toward the y-axis. The x-coordinate also changes. If the b value, or the value that the x-coordinate is changing, if the absolute value of b is greater than 1, we have a stretch. If the absolute value of b is between 0 and 1, then we have a compression. For a vertical stretch, each point is pulled away from the x-axis, so the y-coordinate changes. With a compression, each point is pushed toward the x-axis for a vertical compression. The a value, or the amount that the graph is stretched or compressed, if the absolute value of a is greater than 1, you have a stretch. If the absolute value of a is between 0 and 1, then you have a compression. Notice that that pattern holds true for both horizontal as well as vertical stretches and compressions. When your value is greater than 1 for a stretch, it works for horizontal and vertical. When your value is between 0 and 1 for a compression, it also works for horizontal as well as vertical. We had an introduction to parent functions in this unit. Similar to the way that numbers are classified into sets based on common characteristics, functions can be classified into families of functions. The parent function is the simplest function with the defining characteristics of the family. Functions in the same family are transformations of their parent function. Let's take a look at our common parent functions. So far, we've learned about the parent functions for a constant, linear, quadratic, cubic, and square root. We also covered absolute value functions, step functions, and the identity function. For a constant function, f of x equals c, which would give us a horizontal line. The domain is going to be all real numbers. Remember, domain is x values. The range is going to be whatever the constant is. So y equals c, which is our constant. Our y-intercept will be at 0, c. For a linear parent function, we also have a domain of all real numbers. We have a range of all real numbers, and the parent function intersects the y-axis at 0, 0. As you'll notice, each of our parent functions pictured here, with the exception of the constant parent function, all intersect the y-axis at 0, 0. For our quadratic, we have f of x equals x squared. Our domain, or x values, is all real numbers. Our range is only when y is greater than or equal to 0. As you'll notice in the graph, the red line, which is our graph of y equals x squared, does not go into the negative area of the y-axis. So the range is only where y is greater than or equal to 0. For our cubic function, we have the domain as all real numbers. The range is also all real numbers. For our square root parent function, notice that it is in the upper right-hand corner, or quadrant, which is where the x values are positive as well as the y values are positive. So the domain is where x is greater than or equal to 0. The range is also where y is greater than or equal to 0. As you'll remember, we have to have a positive number for the radicand, or for the x value, which is underneath the radical, because if we have a negative number underneath the radical, then we have an imaginary number. Whenever you take the square root of a number, you should get a positive value. So the square root of any number is also going to fall into the positive area for y. So that means x has to be greater than or equal to 0, as well as y has to be greater than or equal to 0. Here's another picture of our linear, quadratic, cubic, and square root functions, parent functions. I've also included a picture of the absolute value parent function, which I will cover in more detail later. The absolute value parent function is f of x equals the absolute value of x. It looks like a V shape. In Lesson 1.8, you learn to transform functions by transforming each point. Transformations can also be expressed by using function notation. If we have a horizontal shift, remember when we move horizontally, we only affect the x value. So f of x becomes f of x minus h, where h is a positive number when moving to the right, and h is a negative number when moving to the left. For vertical, we change the k value. Vertical changes the entire function, so we add it to the entire function, not just changing the x value. So f of x becomes f of x plus k. K is positive if you move up, k is negative if you move down. When you reflect across the y-axis, you're changing only the x values. So f of x becomes f of negative x. when you reflect across the x-axis, you change the entire function because we're changing the y values. So you do the negative version or opposite version of the entire function. Stretches and compressions change the slope of a linear function. Now we're just going to talk about linear at first. If the line becomes steeper, the function has been stretched vertically or compressed horizontally. If the line becomes flatter, the function has been compressed vertically or stretched horizontally. For stretches and compressions, we have a horizontal stretch or compression by a factor of b. Notice that horizontal, f of x becomes f of 1 over b times x, where if b is greater than 1, it's a stretch. If the absolute value of b is between 0 and 1, it's a compression. A vertical stretch or compression, we multiply a value a times the entire function. If our a value is greater than 1, it's a stretch. If our absolute value of our a is between 0 and 1, it's compression. Notice the main difference between horizontal and vertical. Horizontal, again, only changes the x value, and it's 1 over b times x. Our vertical affects the entire function, so we multiply our a value by the entire function. We will continue on absolute value functions in the next video.